So problem number one looks like this. Let's see, 21. We have 1740000. They do have commas in there. So we want to make this into a scientific notation. So remember, scientific notation is to look something like this. And I'm going to make these last two different colors. The red and the green you don't always have to have. And then we're going to have some exponent. Okay, so right now, things that we could put in here is we could put, notice there's a decimal. So I'm going to go 174. I could stop there. I could choose to put the 0. That last 0 isn't going to make you right or wrong necessarily. So don't sweat it too much. So we now have to figure out what the exponent this is going to be. So looking at our original problem, where does my decimal live right now? Where? Well, it lives before the one down here, but in the original problem, where's the decimal sitting? After 0, yeah, so it's right here. Okay? So what I'm going to do is I need to, so does everyone feel comfortable where the 1.740 came from? Okay, so I want to move the decimal to here, so I'm going to count. 1, 2, 3, 4, 5, 6, 7. So that's 10 to the 7th. When you have an exponent, hey, what's up, Gunnar?
What's up?
What are you up to, man?
What's this?
Thank you. You're welcome, man. One of my seniors only had me for 3 years of math. And look, he survived. Oh,
Barely.
barely. Well, thank you for this. What'd you get me?
Just, steak dinner.
No way. Son. Brother. Cool. I'll see you Wednesday, not next week, but the
25th, yep.
Yeah, baby. I look forward to it.
Thank you, sir.
He already had an A in class, so he didn't buy an A.
How much?
How much?
Yeah.
$1 million for an A. So that way they fire me, I still have money to fall back on. All right, so when this is a positive exponent, when it's a positive exponent, it means it's a large number. Okay? So that's kind of the key to doing these. Okay? May I move to number 22? We good? Let's see. 1, 2, 3. 1, 2, 3, 1, 6. All right, so remember, I'm going to have this, and I have the option to have these last two spots, but I don't necessarily need them, times 10, and there's going to be some exponent we're going to go to. Okay, so I'm going to change this problem to 1, 6. I don't need to put anything in those green slots. If I did, I could put probably 0 and 0, but I don't need them. It's not necessary. Okay, so scientific notation, a number, a decimal, and then at least one more number, but you could have up to 3 more numbers after the decimal. Okay, so I don't necessarily need these right now. I can just put smiley faces. I don't need, those aren't needed. Smiley faces are not official math lingo. So right now, we obviously see my decimal here. I want to put the decimal here. So now we're going to count. 1, 2, 3, 4. So that's 4. But remember I said when that's positive, it's a really big number. That's a really small number. It's a small decimal, right? So that's negative. So negative exponent when writing in scientific notation means you have a decimal in original. Pretty straightforward, agree? Okay. Is this all making okay sense? And I think there's 2 scientific notation problems on there similar to one of the 5 that I'm going to do. Okay, there might be 3, but I think there's only 2. I know I just looked at it this morning. Oh, and also, I took the 50 question final without a calculator. I'm not trying to brag with this. I just want to give you all a heads up. I got it done, all 50 questions, in less than 10 minutes. It was like 9 minutes, 45 seconds. Okay? Now, I realize most of you won't do it in 9 minutes, 45 seconds. You'll be much faster than me. I'm kidding. So how I typically look at that is I think, okay, that would probably take the fastest student in here about 40 minutes to do the whole final, and the slowest student in here, hour and 10 maybe. So do me a favor. You know who you are. If you are a fast test taker, just make sure you maybe bring something. You can't have your cell phones out at all, even if you're done with the final. I'm going to ask that all cell phones are put in over there. Once you're done with the final, if you need to go to the restroom, you can grab your cell phone to go to the restroom. But then when you come back in the room, please put your cell phone back there. Does that make sense? And we're just doing that because you guys might sell pictures of the final, and you profit from it, and I don't get anything. Well, Stirp, what if we give you half? Yeah, I know. It sounds like a really good plan, but we can't do it. 1, 2, 3. 2, 3. All right, we're going to do scientific notation on this one. So remember, dot, or blank, dot, blank. These last 2 slots, we don't necessarily need to put something. And then we're going to have some exponent. Okay? So right now I'm going to have 2, 5. Excuse me. I could put the zeros. I don't have to. It's not wrong if you do. It's not right if you do. Or it's not, incorrect if you don't. So we can leave those blank. So my decimal is living right here right now. I want it to go here. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. Should this stay a positive exponent? Yeah, it's a big number. Big number means positive exponent. Okay? Any questions on those 3? And let's hit 2 more of these. So number 24, we have 5.72 times 10 to the negative 4. And I'm also going to put squeeze number 25 right here. 1.4 times 10 to the third. Okay, first thing when we look at this, what can you tell me about the number? Not worried about what the number is right this very second, but what can you tell me about the number? Is it a small decimal or is it a big number? Small decimal, okay, because it's a negative exponent. So this means I'm going to go left 4 spots. Okay, so this is going to go 1. I need to put a couple of zeros here. 2, 3, 4. Okay, so this is 1, 2, 3, 4. If you would like to, you could put this as well. That's not 100% needed, but you can put it if you'd like. Okay, that's all it is. What about this one? Is this going to be a small decimal or is it going to be a bigger number? Bigger number. So I'm going to go right 3 spots. So right now the decimal's here, so I go 1. I'm going to add a couple zeros. 2, 3. So this is going to be the same thing as 1,400. Okay? Does that make sense, my friends? Not too bad? All right. Let's see. All right, this is not going to be homework. We're probably going to hit, we'll probably hit up to 9 of these questions to stay in class. All for the group. Put it back there. Yeah, stretch your arm out of place. Catch.
1, and 2, and 1, 2. Only one for you. Sorry.
All right, so this is, we're going to be playing around some factoring. There's a couple factoring ones on the test, and we're going to, over the next couple of days, I guess today, Monday and Tuesday, hopefully we can get through and get this finished. But we'll do a little bit of time. Some of you choose to go for it. I just really want to go through it, make sure you feel comfortable with it. So let's take a look at problem number 1. Okay, so I'm going to go back to the language that we know, and we want to factor this. So basically, remember, I'm trying to get this down to 2 sets of parentheses. Agree? So, is there a 1 right there? Okay, so let's look at these the quicker way. As long as we have a 1 in the very front, we can factor it a little quicker. So think about negative 30. In order to get a negative number, I need a positive and a negative to be multiplied together. Agree? So 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, and 5 times 6 is 30. Those are all the ways that I can multiply 2 whole numbers together to get to the number 30. Okay, so now we have to be cautious. I want one of these to be positive, one of these to be negative, and also add to positive 13. Okay, so I know I'm going to have a positive and a negative sign. I'm going to have an X and an X. Okay, so which of those numbers, which of those sets, 1 and 32 and 15, 3 and 10, and 5 and 6, one being positive and one of them being negative, would add up to positive 13. 15 minus 2. I like it. I like it. Okay, now, some of you might be saying, well, what about in 3 and 10? Well, 3 and 10, if they're both positive, they do indeed add up to 13. But remember, I said one has to be positive, one has to be negative. So positive 15 and negative 2, do those work to add up to 13? So ready? X plus 15, X minus 2. Done. So I'm kind of shortcutting kind of how we had done it. And this really is the only way it's going to work. When you have a lead coefficient, your A value is a 1, you can get away with doing it the quicker way. Okay? All right. I'm going to do a split screen. All right. So will you try number 2? Try doing it the exact same way we did it. If you don't have a calculator with you, you're welcome to use your cell phone right now on this to figure out the factors of 24. But try and do it the exact same way we just did it. All right, so let's work through this. So because I have a 1 in front of that, I know I need to break this down to 2 binomials. Okay, so the 2 numbers that multiply to give me negative 24, what do you know about that? What do you know about the signs? One of each, right? Positive times a negative gives me a negative number. Okay, so I know that 1 times 24 gives me 24. I also know 2 and 12, 3 and 8, and 4 and 6. Okay, one has to be positive, one has to be negative to add up to negative 5. Which of those is going to work to get me to negative 5? 3 and 8. Which one has to be positive? Which one has to be negative to get me that? Positive 5 and negative 8. Good. So I got negative 8, positive 3. Problem's done. Okay. So again, this is a quicker way, especially when you have the x squared by itself. And I know when I originally taught it, I was teaching you to multiply the first and the last number together, and then we were factoring by grouping. And on purpose did it that way so you had the same type of topic when we got lead coefficients that were not 1. Okay? All right, go ahead and try number 3. Say how you do. Give you a moment to try that. Okay, so first thing we realize, there's a 1 there. So I know I'm going to break this into 2 binomials. So now I want to figure out the 2 numbers that multiply to give me negative 36. So what do you know about the signs? Plus, minus, good. And then I know that 1 times 36, 2 and 18, 3 and 8, no, 3 and 12, 4 and 9, and 6 and 6. Those are all the numbers I can multiply together to get 36. Agree? Now, please know this. I'm not checking to see if you can do the factors down yet. Does that make sense? Because when it's multiple choice, I'm not going to necessarily look for this. All right, so which of those numbers will add up to positive 5?
4 and 9.
4 and 9. You're absolutely right. Which one has to be negative in this case to get me a positive 5? 4. Good. So x plus 9, x minus 4, done. Pretty simple. Go ahead and try number 4. See if you can work through that one. No. Recording. Good. All right. So I have a 1 out front. Agree? So positive 56. Now, with this being positive, I have to double check. If that sign is the same, that means both signs are what? Positive. Now, if that 15 was a negative 15 and we had a positive 56, that means both signs would have to be negative because negative times negative is positive, okay? So I know that 1 times 56. I also know that 2 and 28. 3 doesn't work. 4 and 14. 5 doesn't work. 6 and 9. And I think that's it. Which of those numbers add up to 15? 6 and 9. Good. Are they both positive? Yes. So you just take those positive numbers, go here and here. Done. Now, here is an option as well. I want you to think about this. Let's say you just can't figure out how to factor the number down. So it's very, very possible you have 4 number choices. So let's say you get to it and you're like, oh my gosh, I can't make this work. Well, start going to your choices and say, oh, what would happen if I were to multiply these out? So this is the answer here, but I'm going to just show you. X squared, 9x, 6x, 54. Add the like terms. Whichever answers come out to what the original problem is the answer. So if you get stuck on the factoring, you can go multiply. Yeah. 56. Thank you. It's 8 and 7?
Yeah.
Dude, I totally did this wrong?
6, 9.
Oh my gosh. That's an 8 and that's a what? So that means that has to be an 8 and that has to be a 7. My goodness, you can't take stirp anywhere with you. Oh my goodness. Thank you. All right, so that means that if this multiplied out, it'd be x squared plus 8x plus 7x plus 56. Oh, I'm so sorry. And then this would add together to give me the answer. Oh my goodness. I am embarrassed. I goofed up. It was not 6 and 9. It was 8 and 7. Oh, you know, I fell right into it. I liked it. You know, it happens. Well, I think on that note, let's call it. Will you bring this back Monday? We good? Rest of the period. Ah, okay. Next one did work. Gotcha. All right, so you do not need to work on this sheet. I think the best thing if you did, maybe just take a look at 1, 2, 3, and 4. Maybe go back and take a look at the other reviews we've been working on. But please bring this sheet back on Monday.